In this video, we are going to talk about using AI to talk to your data. I'm going to go through the common gap between having data and getting answers. I'm going to explain what you can do with Snowflake's Cortex Analyst and also a quick demo of what you can do with it. I'm Amber Lin. I work across data and AI delivery at Brainforge, and I'm here to make you the leader who got AI right. Imagine this. Your data team has finally got everything ingested and modeled in Snowflake. It finally has everything you need. But as the business user, I'm still waiting on something else, and that's the dashboards. I have to wait for everything to be put into a dashboard before I can learn any insights that's useful for my day-to-day. That dashboard may take a long time to build. It might be unmaintained, or it might have outdated data that no longer answers my current urgent questions. Many of you have used some sort of conversational AI, whether it's ChatGPT, Claude, Gemini, and what I'm introducing here is Cortex Analyst. It is Snowflake's version of a natural language analytics engine. So instead of writing SQL, business users can ask questions in plain English and get instant, accurate answers grounded on your actual data definitions. It is a translator between your language and the data system's language. You don't have to wait on a ticket or rely on a dashboard to get your questions answered. For our demo today, I'm going to use a supply chain dataset that has orders, customers, and suppliers. This should be fairly familiar to everybody. Right now, I am in Snowflake with a test account. Let's go to Database Explorer to take a quick look at our data. I'm using the supply chain dataset that has these tables, and I've created a semantic view for our demo. Here are some of our example tables. As you see, we have the customers table, the orders table, the line items table, and the nation table. So let's go to Analyst from clicking AI and ML and clicking on Analyst. I've already selected my schema, and as you can see, here is the Cortex Analyst that I have created for this demo. A semantic view is like a domain analyst that knows how different tables relate to each other and how we should interact with them. This is what will give AI instructions when it's querying your different tables. If you're interested in building one, we will have another video coming soon. Here is a semantic view I created on the sales topic. As you can see, it will list the table stats included, some metrics we defined, and relationships between the table, which tells AI how they can join different tables together. As a starter, we can go into Playground, and let's ask it to explain the dataset to us. So it will tell you what topics this semantic view can cover and some sample questions you can ask it. The purpose of Playground is so that you can tweak and edit your semantic views, because it will show you how the AI was able to understand your data based on all the instructions you have given it in the semantic view. Let's ask a sample question of how many orders do we have? So Cortex Analyst is going to interpret your natural language question and fill in gaps as it thinks. So here, it interpreted our question as how many distinct orders are in a data set. And it generated this query based on the metric total orders that we have defined in the semantic view. So usually I would use this to tweak the metrics that I have added here, or add this as a verified query. More often, I would be using the sidebar, Coco. This has access to all of the database under your role permissions and can generate SQL that's not just limited to your semantic view. But since I am on the semantic view page, I wanted to give me answers based on what I have already defined in the semantic view. So let's test this question again. How many orders do we have? As you see, it will look at the semantic view and realize there's a metric called total orders defined, and it will generate the SQL query grounded on the semantic view, which means it will use the logic that you have written and verified instead of trying to figure out and generate logic that might cause faulty results. And that worked. Tells us we have 1.5 million orders in our dataset, and it comes from the total orders metric that we previously defined. Let's try another question. How many customers are in each market segment? Again, you don't need to write the SQL. Coco already took the definition of segment for you and broke it down by market segment. You can inspect the SQL it generated over here. So you can see it counted the distinct customers and grouped it by market segment, and it also helps you order this table by customer count in descending order. It already knows these things because we have defined this in the semantic view, and you can see it also generates a little bit of insight that you can use for your analysis or for your decisions. Let's try another one. What's our total revenue? So in this case, because we have defined revenue as the sum of extended price after discounts, this is what it uses. So it uses the formula that we have set in together so that everybody who asks about revenue doesn't get the pre-discounted price. If you define something in the semantic view, Cortex Analyst will apply that automatically for you. Now, let's go into some real analytics. Let's do next question. What is the total revenue by region? There we go. What's cool about this is that it joined all 4 tables that we have included here without us having to reiterate how the tables relate to each other. So you can see here we have joined into the line item table, we added the orders table, we added the customer table, and the nation table. They all joined together based on the relationships we have defined here, which enables us to do this slightly more complex analytics. And it tells us that revenue is fairly evenly distributed with Europe in the lead. Now, the next question I asked is related to ranking and also segments. Now, from this simple question, Cortex was able to rank, order, and also limit the number of results that it will show. So it has told us what are the top 5 customers by their total spend and in what segment they're in. So if I want to see another type of question on time series, so I want to see the monthly revenue trends for 1995, and it will show me this table. I'm going to ask it to visualize. You can also ask it to filter. So in this question, I've asked it to filter nations by revenue and by urgent orders only. And from just a natural language question, it was able to apply those filters in SQL and give me the answer I need. You can have multi-turn conversations with your data just like how you talk with your Claude, Chat, or Gemini. So I asked it what's the revenue by shipping mode, and I will then ask just for 1995 to restrict the years included. Alright, and then I wanted to break down by quarter. Alright, so now we have different quarters by ship mode and the total revenue. Now let's try a complex question. Let's do this one. What is the average number of days between order date and ship date by region, and which region has the worst shipping delays? So using this question, your operations team can go in and find those targets to improve your shipping time. There we go. What you just saw had 0 SQL needed to be written. It had accurate metrics that has been defined and agreed upon. It can have multi-turn context, and it can handle complex joins between many tables. And most importantly, it is governed. So it only gives you access to data that your role permits. And to get to that, it only took about 5 to 10 minutes to set up the semantic views. And after that, every single user can self-serve those questions without waiting for a data analyst to write the SQL. Now, there are some caveats that you need to be wary of when you set up this for your entire database. At Brainforge, we don't just throw natural language over the entire database on day one. We go through 3 phases. We start with the foundation. So that's your usual ingestion, modeling, granting roles, and access permissions. And then we start with one pilot domain, which is one or few semantic views contained, using it to prove our first value. So we'll use golden question sets that the business trusts. And 3 will scale. So that means expanding this to more domains, training your team to use it, and enabling you to create and ask questions that you need. And the outcome is going to be fewer tickets, faster question and answer turnaround, and one place to go for all your data needs in Snowflake. And there you go, plain English, real SQL, and fresh from your data warehouse. And in the next video, we'll be answering this question. How do you make sure your AI only answers what it should? How do you keep it from hallucinating a table or inventing a metric? That's the semantic view. It will be the guardrail that makes your AI production ready instead of just demo. So if you're thinking about making the jump to AI for your data, this is how we recommend starting. We help teams put Snowflake, dbt, Cortex in place so that business users can ask questions without leaving their warehouse. It's faster insights, faster decisions, and faster growth. I'm Amber. Thank you for watching. Click the link below to get in touch. See you next time.